and thanks to JPR, we already have part of an introduction, but for such a strategic and highly technical topic, we now need a very special speaker to go into detail and describe to you the 4D new cache manager and how it will bring another level of scalability to the platform.
Good morning. So, it should be very brief. Basically, cache management is one important part of the database management. Right now, up to the new version, the cache is split into 4 large blocks, which could be any size, but they have the same size. So for example, here is a cache of 4 gigabytes. You have 4 blocks of 1 gigabyte, and objects are allocated into one of the area. And whenever memory is needed, in order to avoid fragmentation, data is wiped out of one of the blocks at once, altogether. As much as possible. There may be some memory remaining. For example, if you have a record in memory that is being used as the current record in one of your table, it will remain. So you start to have fragmentation, and more fragmentation. It becomes a problem if you have a lot of tables, a lot of current selection, and a lot of users on your server. You may have up to 20, 30, 50,000 objects that will not be cleared when you need to free the memory, and that will be scattered all along the memory, and you cannot create large blocks anymore, so you cannot load blobs, you cannot load large records, and you're stuck. So, yes, so that was the explanation of all I said, so I'll go quickly when you free. Even if you have more memory, the problem remains the same. Usually you put more memory because you know you're going to have more users, more data to manipulate, but you will eventually have some object that will remain in the middle of your memory that cannot be free at the time you need to free, and you will be stuck again. The other drawback with that mechanism is that you always clear 1/4 of the memory, even if you have a lot of memory. Here we have a 128 gigabyte cache, and we end up freeing 32 gigabytes at once when it's not necessary, in order to try to avoid fragmentation as much as possible. So the idea is to think, okay, we have pointers, we have objects that remains in memory and that cannot be moved until that data is released. But that data could be released very late. It could be if somebody is entering a record, that record can remain on screen for 2 hours if the user goes out and so on. There may be a lot of reasons why that memory cannot be freed right away. So in order to change that, we said, so maybe the best thing is, instead of trying to avoid fragmentation, is to live with fragmentation, to say, okay, we have fragmentation, and what can we do about it? So here, there's an animation, I hate animation, but okay. So here is the way it works with the new cache manager. Actually, it only works with 64 bits, okay? We have a virtual space that is up to the square of 4 gigabytes, so I don't know how big it is. It is 16 billion of bytes. it's a virtual space. Of course, we don't have that much space, but internally, object will be allocated inside that virtual space. So a record could be anywhere inside that virtual space. And we use the memory management unit of the processor, the MMU, to actually map that to physical memory. So the good part about this is that whenever memory is needed, we take it somewhere in that virtual space. It's almost unlimited, so it could be anywhere. And it is mapped to physical memory inside the real memory. So if we have 32 gigabytes of memory, it will be allocated into that. When we free an object, it will be free from the virtual space and free from the physical memory. The physical memory will be fragmented, again, like it used to be. But the good part is that if memory is needed, physical memory is needed, it can be rearranged, it could be reallocated without breaking the virtual allocation, which will still remain. So every reference to that object inside the 4D code and in C++, referencing a record, a blob, an address table will remain the same, so it will not break. The MMU will reallocate this to somewhere else in the physical memory, may even free it completely and recover it later from a different block. It doesn't matter in physical memory. And so that way we work with data that is always fragmented, but it doesn't matter because data can always be reallocated by moving physical memory without breaking the virtual memory, the virtual allocation. That virtual memory doesn't slow down things that much because it goes through a very low-level memory management unit at the processor level, so it doesn't matter, it's as fast. And that way we can work with a very large cache without always freeing 1/4 of the cache each time. And because we now can choose which object we want to free because they don't need to be in a continuous block because fragmentation is not a problem anymore. We have better control of what we want to free. So there will be new command to even allow developer to choose the priority, the weight of tables or index that can be free before other one and so on. It requires to understand a bit of things. In the beginning, I wasn't sure I would give control to that, but Eric told me, we want to sell professional services, so give it to them, so they will make mistakes. No. Basically, the idea is that now you will have control for each table, each index, to set up a weight. And that weight, the more weight, the less likely it is to be removed from the cache. So by default, each table has 10 and each index has 30. But you can change it dynamically anytime you want. You can change it on startup, or you can even change it dynamically while your program is running. And internally, 4D already does that. The new version of 4D already does that. So, for example, when you're indexing now, and you need to do a lot of indexing, it temporarily changed the weight of a table to a very high value and the index to a very low value, so that it loads the record. They try to stay in the cache as much as possible, and the index doesn't in that particular case, because the next index on the same table, you don't care for that previous index. You want the data to be in the cache. So that one way to optimize indexing on large tables. So you will have more and more control about this, and you will be able to keep in mind that this is useful on a large running database. It's very difficult to see the benefit right away on a small database, or even on a database that fits into the cache. If it's in the cache. It starts to be useful when the data is large enough to not fit into the cache, and then there are choices to make, and that's it.
Is that your summary?
Yeah, oh yeah, you're right. One important thing. So we did this, of course, to have a better performances, that's the idea, but also for scalability. So with this, with the new multi-threading, which will allow you to run faster on especially server side, and a better cache management, you will really have the ability to scale to a larger number of users. That's the idea.